In the last video, we explored how to use the OPC UA interface from the connectivity add-on to write robot inputs and read robot outputs, including axis values. In this video, we'll build on that same example and show you how to connect your virtual KUKA robot to the Siemens SIMIT simulation platform. We're using the same setup as before, a robot interacting with 4 different cubes. Let's start by opening the configuration file. First, go to the config dat, then open the user global variables. Here, you'll see a global integer signal that's linked to robot inputs 120 to 135. That gives us 16 bits of data. This signal is queried in the main routine using a switch case statement. The logic is placed inside a loop, and it waits for a rising edge on input 119 before executing the switch case. Depending on the value of the signal color num, the robot jumps into the corresponding case and runs the sequence. This part should already be familiar from the previous video. Now, on a second PC, we've started the Siemens SIMIT simulation. In the SIMIT interface, you'll see a control panel where you can toggle inputs and monitor outputs. Make sure to note the PC name at the top of the SIMIT window. We'll need it later when setting up the connection. Now let's switch over to the iiQWorks.Sim connectivity add-on. First, make sure the connectivity add-on is activated. You can check this under the options menu. Once it's enabled, you'll see a new tab called Connectivity appear in the interface. Right-click inside the connectivity configuration and choose Add Server to create a new server connection for SIMIT. Next, click on Edit Connection. Since the SIMIT simulation is running on a different PC, not locally, enter the hostname or IP address of that machine. In our case, it's PC 18929. Click Test Connection to verify the setup. You might see a warning or error message at first. That's okay. In our case, the attempt was successful. Once the connection is confirmed, click Apply to save the settings. Now activate the connection. You'll see 2 groups appear, one for server to simulation and one for simulation to server. The server to simulation group handles all signals that flow from your external software, like the SIMIT simulation into the iiQWorks.Sim. These are typically input signals. The simulation to server group works the other way around. It sends signals from the simulation back to your server, which are usually the robot output signals. Now that the connection is active, let's map the robot signals to the SIMIT simulation. Right-click the server to simulation group and select Add Variables. You'll see 2 categories, from SIMIT and to SIMIT. For now, we'll start with from SIMIT, which handles the input signals coming from the simulation to the robot. To keep things organized, we'll use the signal maps filter so that only the robot's input and output signals are shown. This makes it easier to find the correct variables. Now go to the input section and select the signals you want to map. In our case, we're mapping inputs 119 to 135. Once selected, click on the button Pair Selected to confirm the mapping. You should see that the variables have been successfully linked. Next, let's do the same for the output signals. These are the signals going from the robot to the simulation. Switch to the simulation to server category and select outputs 101 to 106. You can select multiple signals at once and apply the mapping in bulk. Once done, you'll see the map variables listed below, showing how each input and output is connected between the robot and the simulation. This completes the signal mapping setup. Now both directions of communication are configured and ready for testing. Let's start the simulation by clicking on Play to test signal flow between SIMIT and the robot. The robot inside the simulation is now waiting for a rising edge of input 119. Let's change the input value of color num to 10 and trigger the input 119 to proceed with the robot movement. Since we've set the value of color num to 10, the robot now picks the blue box. At the same time, output 103 is activated. The robot's output signal 101 and 102 controls the gripper. Next, we test with the value 20. Again, we toggle input 119 from false to true. This time, the robot picks the yellow box and output 104 is triggered. Just like before, the gripper closes to grab the box and opens to place it down. Now we test with the value 30. We reset input 119 to false and then set it to true again. The robot picks the red box, and output 105 is activated. Finally, we test with a custom value. Let's say 59. This is mapped to the default case, and the robot executes to the green box. Output 106 is triggered, confirming the gripper action for the green box. This confirms that all signal mappings are working correctly, and that the robot responds to each input value as expected. In this tutorial, you learned how to connect a virtual KUKA robot to Siemens SIMIT using the iiQWorks.Sim connectivity add-on. You mapped input and output signals between the robot and simulation, then triggered robot actions by setting values in SIMIT. Each signal correctly activated the robot's gripper and movement logic, confirming successful communication and mapping.
Thanks for tuning in. We appreciate your support. Make sure to subscribe the KUKA channel for the latest updates and tutorials. For hands-on experience, check out the KUKA College. Until next time, and keep learning and simulating.
Making automation easier.